Hello everyone. In this video, we are going to learn the different subscriber statuses of a user who, who is using 5G core services. In the previous videos, we looked into how your subscriber identifiers and your different location about identifiers work, and we also looked into how your security procedure works. So the subscriber statuses, there are two types of statuses. One is your mobility management status, and the other is your connection management or your session management status. The statuses are similar to what you have in 4G. However, a new status in connection management is introduced, which is basically RRC inactive state, which is introduced on the hand side. A U is connected from the core network, but is in an idle state of RAM. So we will see later in slides how this RRC inactive state works. Right. So the first is the mobility management state, which is in 5G. It is called registration management (RM). So your RM state model in a UE can be in RM deregistered state, where a user has a registration rejected, or it can be RM registered state. So if a user performs a registration request and it is accepted, so user moves from deregistered state to registered state. And if deregistration is done or your registration is rejected, the user moves from registered to deregistered state. Similarly, if you perform a registration update accept, in that case as well, the user remains in RM registered state. In case of AMF, it's quite similar. Upon a registration accept, you move from deregistered to registered state, and in case of deregistration or registration reject, the user is moved from registered to deregistered state. So when a UE and the AMF are in deregistered state, UE is not registered with the network. AMF may store some UE context, but does not have any valid location or routing area information. A UE selects a PLMN to initiate registration procedure, and if it is accepted, then a UE moves from deregistered to registered state. And in case AMF rejects the registration request, the UE is going to be maintained in its current state of RM deregistered state. And in case the UE and AMF are in RM registered state, mobility registration procedure to update the UE location, mobility registration is done to move the user from deregistered to registered state. It can perform a periodic registration update, which we used to call periodic tracking area update. It can perform a registration update procedure, and it can perform a deregistration procedure. And when a user is in registered state, it has a valid location information stored in the AMF. The second one is your session management state, which is called your connection management in 5G. So a user can be in CM idle state and can be in CM connected state. In case user is in CM idle state and it establishes an access network connection, it is going to move from idle to connected state. And in case the signaling is released, the user is going to move from connected state to CM idle state. In case of AMF, then your N2 context is established, the user is going to move from idle to connected state. And in case your N2 context is released, the user will move from connected to idle state. If you remember, N2 is the interface between the radio access network and AMF. So once your connection is established, user will be in connected, and it's released, user is going to be in idle state. So when UE and AMF is in connected state, UE has a NAS signaling connection with AMF, and it has N2 and N3 connection. The N2 connection is with access network, and N3 connection is between AMF. It is between SMF and UMF. The UE reachability information is the cell and the base station information. So your exact cell and your base station information is stored in the AMF when you are in connected state, and your uplink, downlink, data services and signaling procedures can be performed when you are in connected state. In case the UN AMF is in CM idle state, there is no NAS signaling connection. The reachability information is the registration area, which is sort of your TLS. So previously it was called TLS, now it's called a registration area. And to move from connected state, the UE needs to perform a service request, and if it is successful, user is going to move to CM connected state. And when AMF has data to be sent to UE, as in 4G, it is going to send a paging request to UE in the registration area in whole of the TLS to execute the service request procedure. So you're in response to your paging request, the UE is going to send a service request. And based on that, if it is successful, UE is going to move into connected state. And once in connected state, then the AMF, if it has any data, it is going to send to you. The third state, as we discussed, which is introduced, is your CM connected with RRC inactive state. Okay. The thing is that in RRC inactive state, the UE is in CM connected state on the core network side. So on core network side, the CM connected state, but that the RRC connection is released between UE and RAN side. RAN configures the RAN paging area and the periodic registration update timer for UE. So before keeping the UE in inactive state, it is going to send the periodic registration update timer, and the UE is going to perform the RAN area update procedure based on these timers, which are sent by RAN to UE before turning off this RRC connection. Okay, the purpose of doing this is that whenever a UE goes from idle to connected, a lot of service requests and signaling is involved between RAN side and core side. So in order to reduce the amount of signaling, and in order to ensure that the connection is restored quickly, the RRC inactive state is introduced here. So in RRC inactive state, the UE context is stored in the RAN side. The N2 interface between RAN and CN is not released, but the RRC connection between UE and G0B is released. So this connection is not released. This is released. So you say, so once the user perform a service request or a periodic RNA update, the signaling here is saved. And RAN determines whether UE enters into the RRC inactive state based on different timers which are configured in RAN side. Right. So this is a call flow of RRC connection restoration. So UE is an RRC connected state, and UE wants to send a message, so it is going to send an RRC message. The RAN is going to perform the context retrieval. It is going to send a message of N2 path switch, and once your path is restored, and your path information provided by the UE is sent by the RAN to your serving AMF, it sends back a response of your RRC message. Then the UE then becomes an RRC connected states. And here the user remains, user was already in the CM connected states. So user is going to remain in CM connected state, but in between UE and RAN side, it moves from inactive state to RRC connected state. And in case there is an RRC status change, so the AMF is going to request the NG-RAN to send an RRC status change notification of UE, and then the NG-RAN then notifies the AMF of the RRC status change once the change occurs. Okay, so AMF is going to send that, okay, whenever there is a UE state change, please intimate me. And once the UE intimates that there is a change of status, it is going to send a UE notification, and it is going to send an acknowledgement of that, and it may send a cancel UE state notification in case it does not need an RRC status change required. Right. So this slide is now completes the status related information of a UE in 5G core, a little bit of recall that this similarity and difference between the 5G UE status and EPC. So in 5G, we have an registered and D registered state, as well as CM connected and CM idle state. The differences is that there is an additional state introduced in CM connector, which is called CM connected with RRC inactive state, which is basically introduced to reduce the number of signaling interactions. And the difference, the detail of the CM connector state is that in CM connector state, RRP connector state, the downlink data can reach the G node B, but G node B cannot forward the data to UE. Okay, so it needs to have a paging function available, and based on paging, the UE is going to send a service request, and once this session is established, then the G node B can forward the data to the UE. The different timers are basically your TAU update, the TAU timer, and your reachability timers are these two things which need to be provided in the earliest side in order to ensure that your paging function can be initiated. Okay, so this marks the completion of this subscriber status in 5G core. I hope it was fruitful to you and you got to learn something in this. Till next time, thank you.